Good afternoon, everybody. This is the first, hopefully, of a number of lunchtime seminars the Environmental Waste Management Group is going to be running. We've taken advantage of Chiltern Branch moving from their weekly slots to a 2 weekly slot by picking up the middle week between 1 and 2 o'clock on a Wednesday. We've got 2 further presentations being given. One is in 2 weeks' time, the 5th of August, Dr. Igby Abanga on bioaerosols on composting facilities. And then we're going to speak on looking at zero emissions, transport, climate change and urban planning. So again, we are trying to engage with IOSH members on topical subjects. And please, through the IOSH LinkedIn webpage for EWMG, if you have ideas or you want to present, please feel free to drop us a line and drop me a line as well through LinkedIn. We're happy to follow up every idea that we have. The next point is to mention that for those IOSH members, don't forget to vote in the council elections. So today we've kindly got Dr. Stuart Wagland, the Senior Lecturer in Energy and Environmental Chemistry at the Centre of Climate and Environmental Protection at Cranfield University. His expertise is around biomass and waste, energy and management, waste management and resource efficiency, and carbon, climate and risk, and renewable energy. And I'm using his bio from the internet, so I do apologise, Stuart. He's an experienced waste management professional applying his background in chemistry to understanding waste characteristics, developing novel analysis techniques and recovering value from waste materials. He's a PhD in waste chemistry from Cranfield University and all his other degrees, including a BSc Hons in chemistry and MSc in display technology. And he's a member of the Royal Society of Chemistry and a fellow of the Higher Education Association. So a great guy his contact details will be at the end if people want to speak to him. The topic of today is of interest because my own university are interested in working with the network that is being set up. My personal experience as from the mining sector, I remember many years ago in Dorset when we were actually mining ball clay, and a company called Hall Waste, I think it's now Viridor, were putting waste material in there. And I said, within my lifetime, I bet we'll be mining it all again. So that's a nice topical start to hand over to Stuart, and away you go. The floor is yours. Thank you.
Thank you very much, David, for the introduction. And good afternoon, everybody, and thank you for joining today. The topic I'll be talking to you about today is enhanced landfill mining in the UK. And this is a topical area of the waste management sector now. So I've been involved in this sector for some 10 years. I've been in the waste sector myself for nearly 20 years. And it's an area of great interest of mine. We've been involved in a number of research projects, and so today through this presentation I will introduce some of the data that we've obtained and give you some ideas on what the next steps are. So in terms of what I'll be covering today, so I'm aware that enhanced landfill mining as a phrase itself is quite likely to be a new term to many people on this webinar. So I'll introduce what the concept of enhanced landfill mining is, but also give you some ideas on the UK landfill legacy. So we have a vast number of landfills across the UK. You can see on the right there's an image showing historic landfill sites across England. And I'll take you through some of the sampling work we have done and also some of the data that we've managed to obtain for all of our site characterisation work that we have done. Given the nature of this, of your group and institute, it made sense for me to touch upon the risk associated with landfill mining and site remediation. And then we'll look to where we're going. So what's the next steps? What are we planning to achieve in Europe and in the UK? So a number that I always remember being very surprised at seeing this number many years ago, but we have over 20,000 sites In fact, the total number in the UK is something like 24,000 landfill sites, historic and permitted. In 1974, there was the Control of Pollution Act, and that required landfill sites to operate with a licence or permit. So of those 24,000 landfill sites I mentioned, only 4,000 of those actually had one of these permits. So 20,000 historic landfill sites exist across the UK. We're still, unfortunately, disposing of vast quantities of waste in our landfill sites from all sources. So household waste has decreased dramatically in recent years, largely coming from the Landfill Waste Directive, which specified our need to divert waste from landfill. Our recycling has increased, although it's now stagnated in recent years, and the increase of our energy from waste capacity across the UK has also allowed us to divert waste away from landfill. But even so, there's still lots of waste going to landfill. Now, some of the waste does need to go to landfill in some form. So, particularly hazardous material that cannot be treated in any other way. So there is a need for some form of landfill to exist. But we have a legacy. So there's millions of tonnes, hundreds of millions of tonnes of waste material existing in old and closed landfill sites. So that gives you a rationale for why we're looking at this as an area of development. So some of you may have heard the term landfill mining, and I'm talking about enhanced landfill mining. So on the left-hand side here is a definition of landfill mining given by Joachim Crook, who's based in Sweden. So landfill mining is essentially the process of just excavating material that's been previously buried. But enhanced landfill mining goes a bit further than that. So it's the complete picture of recovery. So waste to material, waste to energy, and using the latest and most innovative technologies in which to transform that material into usable resources and to recover the land. So landfill mining itself is just limited. It's a very crude method, mostly used for the third bullet point there, which is excavation for reclamation of land. So there's lots of activities going on in the UK at the moment where previous historic landfill sites are being excavated, and the land is being remediated for housing development. Enhanced landfill mining will go a bit further than that. So it will involve the reclamation of land, but it includes the in situ and ex situ recovery of all resources within that site. So landfill mining, enhanced landfill mining itself, had a role to play in the circular economy. Now, the circular economy has been particularly eminent in the UK, but across Europe as well. And it's always been spoken about in the context of existing waste material. So there's the diagram of the circular economy, which comes from the Ellen MacArthur Foundation. And you can see landfill at the bottom there, and that's seen as a leakage. And the assumption that this diagram makes is that landfill is the end of life. Everything that goes into landfill remains there. And that's not true in the case that we do have existing landfill gas recovery. So until recently, landfill gas was one of the leading sources of renewable energy in the UK. So that's not represented in this diagram. But through the implementation of enhanced landfill mining, there will be possibility to recover valuable resources and materials for reuse in the manufacturing and supply chain, substituting raw materials. So this is the key component of enhanced landfill mining. It's the upcycling and reuse of valuable materials which have previously been discarded. Waste to energy is a key component of that. So there will be gas being produced from a landfill. So that's an in situ landfill mining example. But there will also be material which is excavated from landfill sites, which is not economically viable to reuse that or recycle that. and that material may end up in a waste to energy plant. Waste to materials, it's the reuse of any metals that we can recover, any plastics being recycled in the conventional sense. Later on this slideshow, I'll talk to you about the plastic degradation which occurs in landfill sites, which makes conventional recycling challenging. As a chemical feedstock, one of the things that we are looking at, certainly at Cranfield, is the use of advanced thermal technology to convert plastics and fossil-derived materials into a chemical which can be used in manufacturing or as a fuel. So that could also form part of an enhanced landfill mining portfolio. And then the land restoration and reclamation. So once all of this material has been taken away, you're still left with land which is partially contaminated and so will still need to be cleaned and remediated. But the end result will be land which can be developed in whichever need exists in that local area, most likely housing estates. This slide gives you a brief idea of what we're looking at here. So we've got material being excavated. Now, one of the main differences between processing waste from a landfill site and processing waste from a household is the existence of soils and fines. Now, this is a significant fraction of the material that comes from a landfill site, so it does need to be carefully considered. And many studies in the past have looked at placing that material back into the site. Now, we're talking 60%, up to 60% of all the material which is removed from a landfill site is soil and fines. So if we are removing that amount and putting it back in, it's going to be very difficult to justify the whole process in the first place. The paper, the plastic, textile, wood, metals, all can go through reprocessing, recycling. There's a question mark there though because of the level of contamination and the degradation that exists. Is it viable to do that? So all of these have questions linked to them. So I thought it'd be useful to walk through what we've done in the past. So this represents perhaps the last 5 years of research that we've done at Cranfield. And it's been funded under a number of different projects and guises. First of all, initiated by one of the major waste management companies in the UK, who had questions about the operation of their sites and needed to know more information about the biodegradable content within their sites. And while we were doing that, we took the opportunity to look at metal contents as well, to look for any inhibition of any biological processes, but also to consider what other resources might exist. So there are a number of publications in that bullet point list at the bottom. If anybody wishes to have a copy of these, please do send me an email. I'm happy to share these with you. So this is a site that many of you may be familiar with. It's a landfill site. On a particularly sunny day, you just see the gas flows there, and this is a site which has been long since closed. There's been trees planted on the top of the site to make it look nicer, but the energy recovery still exists there. So this is our core drill, then rolled onto the site, and we took a large number of these core drills and we took them back to Cranfield to analyse them. So each of these bags here represent 1 metre of that drill. And so some of the samples we have collected in the past, about 40 to 50 metres deep. So we have a significant number of samples representing a core right from the very top of the landfill site right down to the very bottom, including in some cases the very bottom liner. So we do seem to have a very good profile of what is in a landfill site. It's not to say that the sampling that we've done is completely representative of the whole site, because over the course of the landfill operational years, the content going into the landfill site will vary dramatically. So what we have tried to assess here is the composition, layer, profile, to kind of give us a feel for what's in that site. Okay, so this is one of the samples that we removed from the site. This was a catalogue, which was inside when we opened it up, was perfectly readable, and it was some 10 years old. So it's very interesting to see this type of material being taken out. So it just goes to show really that even paper in a landfill site doesn't degrade us quite to the same extent as we'd expect it to. Okay, so the composition that we managed to obtain from the samples that we took. So this is the average of every site that we have analysed. And one of the main trend here is the composition of organic materials. So this is a significant quantity of soil-like material that were taken out of a landfill site. So although the term organic, it really does mean fines and soil-like material. So we weren't pulling out whole pieces of fruit. The material we've taken out here was not recognisable. It was just mostly soil-like material. And it's a significant proportion of all landfill material. And when it comes to material processing, it is a challenge. You can see here it emphasises that trend even more greatly. So you can see the organic fraction is very high. Also, the plastics are quite high as well. So ranging from 15% upwards. But one in the middle there with 45% was perhaps unusually high, but 15% to 25% would seem to be around the normal range that we would hope to see, and that gives us confidence that there are materials in that landfill site to be recovered. But one of the things that we were interested in understanding was what is in that organic fraction. So this significant amount of material that needs to be dealt with. Is there an opportunity for resource recovery within that? So we've analysed that organic material. So here you can see a profile. This is a 22-metre deep site, and the average on the right-hand side there. But you see the organic material is prominent throughout. Lots of glass and metals. Some textiles existing in certain hot spots there, not 8 metres and 14 metres. Lots of plastics throughout as well. So we had a look at the metals of the organic soil-like material, and cerium and lithium were clear there, around 20 milligrams per kilogram. However, the main point that we noticed was a significant quantity of copper and aluminium. Now, it's entirely theoretical, of course, so we're not going to be able to recover all of that copper and aluminium, and some of it will in fact be background copper and aluminium that naturally occur in soil content. But one of the researchers at Landfill, we've managed to calculate that if across all 4 sites, assuming that content was consistent in all of the soil and fine fraction, that would amount to about $200 million worth of copper and aluminium. So it starts to give us an idea of the amount of resources that can be recovered from landfill sites. We also had a look at the distribution of heavy metals and valuable materials across all of the fractions that we recover from landfill sites. So we're in 2 different sites now. But one of the things that you'll see is that the lead and chromium are quite high, and they are clearly a concern. Aluminium, copper, as I've mentioned already, will give you recovery opportunities. The rare earth elements, they exist, but they are in such low quantities that you wouldn't mine a landfill site just to recover those. So in terms of an enhanced landfill mining platform, it would require the recovery of plastics, textiles, wood for reuse or energy, but also a very innovative recovery of metals in all fractions. Of course, no waste characterization of this nature is complete without looking at the combustible fraction. So we wanted to have a look at the calorific value. And once we remove all of the soils, so leaving behind roughly 30% of what we remove from a landfill site, we're left with a waste-derived fuel which have a calorific value similar to that of household waste. A lot of studies in landfill mining and enhanced landfill mining like to look at the use of plastics, and they simply assume that plastics can be recovered and recycled in the same way that household plastics are. However, we've looked at this, and the degradation and contamination of plastics recovered from landfill is much greater than we anticipated. So the bottom scan electron microscope images can show the level of cracking and shearing of the plastics. They're also very dirty. There's lots of contamination stuck to the surface of this plastic. So one of the things that we have been investigating at Cranfield is to convert these plastics through advanced thermal treatment, in other words, pyrolysis, to convert these plastics back into a monomer unit for the production of chemicals and liquid fuels. And that work so far has shown significant promise in being able to do this. Again, there's an article which we published some time ago, or earlier this year, which will give some greater insight into the polypropylene and polyethylene we've analysed in these sites. That's open access, so please feel free to follow the link below, or to search the title of the article and download it. Again, if you have any issues in finding that, please send me an email. I'll be more than happy to send it to you. One of the big projects that we were involved with was it's a European Horizon 2020 funded Smart Ground project, where we look to develop a data bank of secondary raw materials across the European Union, using pilots from all over Europe, in Hungary, Italy, Spain and the UK. And through that we developed a bit more of an understanding, and we developed a decision support tool to be able to assess whether or not a site was viable for enhanced landfill mining. These two articles are again both open access, so if anybody would like to download them, please look for them. Again, I'm happy to share these with you, including the decision support tool if you need it. And this is what waste looks like when it comes out of a landfill site. So it looks like a lot of plastic, but once all of this is sieved and moved around, there's a significant proportion of fines. So we can't just remove waste from landfill and process it in exactly the same way we do with household waste or in commercial waste. So the fines need to be dealt with. And the plastics look like a lot of film plastic there, in fact, but the weight of that plastic as relative to the entire waste stockpile will be quite low. So one of our project partners on the network, which David mentioned before this presentation, is Vertase FLI, who are experts in land remediation. They've done lots of landfill mining projects across the UK. This is an image showing a very crude separation techniques to separate heavy inert materials from plastics and the rest of the waste material. So they don't undertake what is clearly defined as enhanced landfill mining. They do landfill mining for the purpose of redeveloping a site, but they do aim to recover material at the same time. Now, one of the things that we need to think about is the risk, and the risks in this context include the risk to human health, but also the environmental risks. So we take a closed landfill site, and most landfill sites to some degree will pose a long-term risk to the environment and water sources. There's an article from The Guardian on the right-hand side there showing lots of evidence that UK rivers are being contaminated by ammonium from landfill sites. The other aspect of any site, especially historic and legacy sites, is that the records are limited. In some cases, all we might know is that there is a landfill there, but we know very little about what was deposited into that landfill site. And that gives us a huge challenge in understanding what the risks are involved, but also what the commercial opportunities are in recovering materials. So the in-situ recovery is the gas extraction and combustion and treatment of leachate. Through the leachate, we've got an opportunity to recover any metals, albeit a very small chance of doing so. But the in-situ recovery, apart from the conventional risks in processing a combustible gas, and these actually help reduce the environmental impacts of a landfill site. So they help manage the gas release. But this is the main area of risks. Well, this is where the main risks really start, and this is the great unknown we're moving into. So once we know what the site might contain, we might do some drilling, some core drills to just check. But once we start excavating the site entirely, we may end up finding materials we didn't know were in there. So core drilling won't necessarily highlight all the risks involved. So there might be some exposure to the air of materials. We're also dealing with sites which might have some pockets of combustible gases, so exposing that to air comes with its own risk. But we've got the release of gases to the atmosphere, exposing site workers and anyone in the vicinity to those gases. Airborne compounds, so it could be heavy metals or bioaerosols. But the other one is asbestos fibres. So we've done lots of analysis at Cranfield, and asbestos is one of our main concerns. So the protocol we operate on is that the samples arrive completely sealed. We have an area of working which is completely locked away, and completely isolated from anybody else. And the researchers working there are wearing a full body suit with face masks, ready for any asbestos fibres to be evident. We send a sample of that soil to the laboratory for fibre testing, and if it comes back negative, then we will treat it as we would as a conventional waste material. If it comes back positive with any asbestos fibres, we seal the entire sample and dispose of it as hazardous waste. So it's a risk that we're very much aware of and concerned about, but that's only in the laboratory setting. In the commercial setting, with a whole landfill site of many hectares, there could be a pocket of asbestos fibres which any site investigation may miss, and so that risk remains a concern. So that needs to be carefully managed, and it doesn't just expose site workers, but it could be anybody living or working around the site, which need to be considered. So this is a challenge, and part of the network that David mentioned, we're looking to bring together experts in this area to understand and develop a framework for implementing enhanced landfill mining in the UK. So I'll come on to that shortly, but part of that network and framework will be the health and safety and environmental risks. Processing of excavated material is also in a similar context as the excavation. There's still other risks over and above handling standard non-hazardous waste. So the soil is a significant component, but it is also heavily contaminated. Lots of metals have leached through that soil, and it is in itself a risk. Again, there's potential for asbestos, and all of the recoverable materials are heavily soiled, so we'll need cleaning of some sort. So that involves the potential of dust and water runoff and other contamination, which is not seen in normal waste facilities, or not conventionally seen in waste facilities. And then the remediation of site. So this is an area which comes under a remit of contaminated land, and so we're working with Claire, the contaminated land specialists, and to help implement that into the enhanced landfill mining framework. So that's 5 very broad areas of risk which I've identified as just here, and there will be challenges throughout the whole process, and it really does need careful consideration. And the other aspect of it all really is that every site will be different, so we'll need a complete new plan for every site. So I've mentioned that enhanced landfill mining has been gaining traction in recent years. So in 2014, the European Enhanced Landfill Mining Consortium was established. There's been work going on beforehand. We were doing work before that time, and we were founding members of that consortium. And through that consortium, we were able to contribute and win European funding from the Horizon 2020, but also Interreg and ERDF funding, to working specifically on enhanced landfill mining and sustainable landfill management. This led to us debating in European Parliament for the inclusion of enhanced landfill mining into the Waste Framework Directive, which gained favourable responses. It's still yet to fully be implemented, but it should then start to pave the way for national policies and governance to allow this to happen. And so I think this slide really demonstrates that this enhanced landfill mining, just on a European level at least, has considerable interest in funding. So since the formation of ELFM, we've managed to secure over 14 million euros of funding. And Regeneratis in the bottom right there is the most recent project. It started in September last year, and Cranfield are part of that project. And that will look at metal sites, former metal sites and brownfields. So it still has relevance to enhanced landfill mining activity. In the UK, it's still starting to gain traction. So a couple of years ago, we featured in the Financial Times, and it was identified as one of the 50 ideas to change the world. So enhanced landfill mining is starting to become a key area of research and development, but much work needs to be done. And recognising that Cranfield's role in ELFM will soon start to diminish as we've left Europe now, we started to put together a UK enhanced landfill mining network. It was launched earlier this year. The web link's there. So please do have a look at our website, and you're welcome to join. If you go through the website, you'll find the contact details there, and you can apply to join the network. This network brings together sector experts to develop expertise and try to deliver the vision of delivering enhanced landfill mining in the UK. So Cranfield, although we've done lots of work on investigating landfill sites, we don't have the numbers to be able to enforce regulation and change policy. So we're trying to come together and work in a large consortium to help us achieve that. So just since our launch, earlier this year. In fact, it was last month we had our first ever webinar. These are our members so far. We've got lots of other companies and organisations who are keen to join us. We're talking to all of the regulators across the United Kingdom, Environment Agency, Natural Resources Wales, SEPA. We're also talking to DEFRA to try and understand their perspective of this as well. And we're also working with all of these partners to try and come up with a national framework for how enhanced landfill mining will be implemented in the UK. So I hope I've given you an idea of what landfill mining is now. I'm by no means a health and safety expert, so I'm keen to meet up and join people that do have that expertise. But landfill remediation is vital for pollution prevention. It's actually happening now. So landfill mining in the old context is happening right now and has been for a number of years. But enhanced landfill mining gives us that mode of recovering valuable resources, actually makes landfill remediation more cost effective, but contributes also to the UK circular economy platform. But it's not without its challenges. So we really do need to have a joined up way of thinking here for the technology needed to recover materials and to process the materials being recovered to obtain any value from them. But there's also the regulation. So the regulators will need support in how they assess each site and approve such an undertaking on the remediation of the site. But also the health and safety platform is significant here. So we need to ensure that not only is the environment being protected during the excavation and recovery of resources, but also the people working and living nearby. And that happens at every stage of the process. And then of course the final one is the financial. It is not commercially viable to mine every single landfill site in the UK, but there are a number of landfill sites which contain significant resources and are in areas where the land value is substantial enough that enhanced landfill mining is economically feasible. But it still needs to be done with regards to the regulation and health and safety of the site. So my contact details are there, and you're very, very welcome to send me an email or any questions that I don't have the opportunity to answer. And the Enhanced Landfill Mining Network, the contact details are also there. So if you send an email to that address, you'll be given instructions on how to join the network. So I hope that's been useful and interesting. I now await some questions and comments.
Hi, thank you very much indeed, Stuart. The first question is, I'm going to throw, I might give you my steer to start with as well, because it's from the health and safety element. Are the HSE being consulted as a key regulator, as well as environment agencies? And I think I was going to pitch in the slide you showed with the construction site, with the housing development and the landfill mining towards the photographer's end. When we had the conference, it was interesting that the HSE is involved, but it's not the environment, it's not the waste or the manufacturing sector. It's actually under the CDM because it's actually all a construction site. So it seems to be, where the HSE are being involved, it is through the F10 notification. And that was, I think, the discussions we had at our conference, and I think we left it as who would be interested at the HSE. I think the manufacturing sector, who are the waste management experts, and that now we link with agriculture because it's a high risk, may have a say, but it's way off their radar at the moment. Any thoughts on that, Stuart?
Well, I think it needs to be on the radar, as you say. It's not something we've spoken to them about yet, but some of our project partners have. So this is where we need input from those that are working more closely in that space, such as yourselves, to help the network itself grow in that regards.
I wear two hats here. One is the academic role at Middlesex University, and second is the chair of the EWMG, where we have roots through. So the key thing is actually to take it for strategic decisions, to take them away from field inspectors to the strategic group at within the HSC. I think that is the key thing. At what point is done as well, because what you want to do is this balance between the right people getting involved, because the support with the Waste Industry Safety and Health Forum, which is very much to be engaged with the industry to make things happen, rather than to block things, yet looking after worker safety and health. So that I think is a delicate one, I think, to pursue, and I think one I think you rightly picked up. Can I go to the other questions? Brexit keeps appearing. Is Brexit a game changer for enhanced landfill mining in the UK?
Do you want me to answer that?
Yeah, is it a game changer? I mean, you mentioned the setting up of the UK-based network, which is in parallel to the European one that we had, you mentioned a couple of slides back.
It's a tough one to answer, I think, and it's probably too early to say. The likelihood is that the UK will continue to comply with any European directives on waste, so the Waste Framework Directive will still remain relevant in the UK. But we do have an opportunity here to be more ambitious in our circular economy than the European package currently dictates. So in that sense, this could actually allow enhanced landfill mining to become more important in the UK, allow UK to become a sector leader in this.
Okay, and the next question is, will the EU work continue after we leave the EU?
Well, it is at the moment. So Regenerative was funded just before the cut-off, and we've still got 3 years left to go on that project. So it's still being funded by the EU.
And that ties into the next question, is how will your projects be funded after Brexit? Or how will they be funded after the 3-year period? I think that's the...
Yeah.
I think we're all asking these questions in academia, aren't we, at the moment?
Absolutely. Well, I think there's an opportunity here for UK companies, organisations and universities to come together to look at UK RI funding. There could be some green investment banks aspects of it as well. I think there is opportunities in the UK to carry on funding this work. I don't think we need to be reliant on EU funding. So although I've given the big guns in terms of our projects being the multi-million-pound projects that we've been involved with, they're the European projects, but we have secured lots of funding from the UK as well. Okay.
Has the government got a grip of the potential of recoverable assets in these unusual days and the £1.85 trillion debt? It's a wonderful question.
I don't know. That is a very good question. In fact, it's something I'm going to have to go away and mull over. I don't think I'll be able to give a fair answer to that now.
I mean, I would go back with my local government experience and say, don't expect the politicians to know actually what goes on. So by government, do the politicians know, and by the civil service and our things like our sectors, is there engagement happening? I think you mentioning DEFRA, so DEFRA are coming new into it. So the answer probably is government don't know, but DEFRA is on the DEFRA as it were, their radar. Has enhanced landfill mining been undertaken and commercially successful to date?
No, is the answer. Landfill mining has been undertaken to date multiple times, but only for the reason of redeveloping a site. So it happened, and it's been done by Vertes, FLI. I gave you a couple of images of what they've been doing. We're not the only ones who are operating in this space either. So it's been done with the aim of building housing on an old site. It hasn't been done under the complete umbrella of enhanced landfill mining just yet.
Okay. The next question is, maybe we can tackle this one together, but I'll give you first shout, Stuart. Segregation of recovered materials is, in respective components, is a big challenge. It's labour intensive. Any way to tackle that challenge?
Well, the main challenge is the separation of soils. So through sieving and trommeling, you can remove much of that, but then it's still how do you manage that soil fraction afterwards. So, but a lot of the technical solutions exist in the waste management sector now, but it's a configuration that would need to be carefully designed for a landfill mining project. And that would involve separation of a much larger soil fraction than we expect to see elsewhere.
It's worth noting that some of the MRFs around the world, I mean, some of the technologies are quite advanced, but the big challenge is getting the quality of material at the earliest pass possible. So you don't want to be having to resort and resegregate material. You want to be one pass through a system. And even for the best plants, we're talking about 95% recovery rates in terms of efficiency. And there are things that you can't afford to get glass in paper, for example, so no. So, I mean, in some parts of the world as well, there's a manual element. There are litter pickers, people actually in cabins doing quite unhealthy work. So there are real health risks already in the waste sector for sorting recyclables into their appropriate components. So that is an ongoing challenge, and I think technology is on the case, but whether technology is where we as health and safety professionals want it to be is another question. Can I get away with that, Stuart? Can I? You happy with that?
I think so, yeah. I think that's a good answer.
Can ELFM be used to offset against business carbon emissions? And if so, how is a recognised method of doing this?
Well, thank you, Colin, for that question. That came up in our webinar last month, actually, for financing these facilities, financing these processes. It's certainly something that would form part of a UK framework. So we would need to put the procedures in place to make that clearer. I think that's definitely a very good question, though.
Okay, well, the next one really is, have you approached, I've been working with the Chartered Institute of Waste Management on this. They're a special interest group looking at health and safety in waste. I'm sure they would be interested. It's worth noting the Environmental Waste Management Group, we've got a very close relationship with the COWM Health and Safety Group. So, you know, if need be, we can help make connections there. But from your point of view, Stuart, have you gone as far as COWM?
We work very closely with CRWM. They used to accredit one of our MSc courses at Landfill, so we know them very well. We haven't spoken to their special interest group in health and safety though, so that's a follow-on action for me, I think. I think
it'd be good actually to get the three of us around the table. Our group, EWMG, that is health and safety group, looking in the waste sector, the waste sector looking at health and safety in yourselves. It could be an interesting discussion. We have worked collaboratively together with projects with the public sector, believe it or not, in the past. So those were all the questions so far. Are there any more questions people want to throw in? It's 7 minutes to 2. I'm mindful that I don't wish to go on much beyond 2, and short and sweet is always better than long and winding. So are there any more questions to Stuart? Because if not, I'm going to thank Stuart very much for his time and effort in doing this. Having been involved in the work before, I think it is something that's going to carry on. Resource management and getting resources, I think, is topical. I think the demand for them, plus the demand for energy, will also continue unabated. And that, I think, is a problem that all of us have to be involved in. So thanks very much. I hope to see everyone then in 2 weeks' time for Dr. Igbiabanga from the University of Greenwich looking at bioaerosols, which I think is very, very topical. If you're into food waste collection, you're into composting of materials and you have your bins collected, you might want to know some of the risks that maybe some of the bin men are having to face that isn't maybe mentioned in your council literature when it comes out. Again, if anybody here wants to present, and I hope, thanks David W, thanks you. Yeah, so everyone who wants to present, please come, please drop us a line through, either through IOSH, through LinkedIn, and we will hopefully be able to incorporate you into our fortnightly schedule. So thanks again to everybody. Thanks again, Stuart. Any more passing words before we go? I can let you get your lunch.
Well, no, thank you very much for inviting me to present, and thank you for everybody for the questions. Again, apologies for any of the sound quality, but any sound quality problems we had at the beginning. I don't know why that was, but hopefully it was resolved.
Brilliant. So in that case, I'll let everybody get on to the rest of their day. Thanks very much indeed, and have fun. Cheers. Thank you.